Alright, so this is number 3 on the worksheets for projectile motion. We've got a frying pan that's being thrown with a speed of 25 meters per second at an angle of 35 degrees upward. How far does it travel? So it's just like the soccer problem, really. Let's give it a try. We're going to assume that's going same level to same level here. And it's going to make the path of a parabola. This is the closest thing I've got to like a parabola here, so we'll use that. Boom, like that. Not quite, but it's, you know what I'm trying to draw there. And then we know that the initial velocity, it's kind of a steep angle for what it's actually saying. It's going like that. Like I said, it's not the best drawn parabola, but it will work for what we need it to do. The parabola here, you know what, let's just delete that. That's bothering me, that parabola. Doesn't look like that at all, so goodbye. Here, let's try drawing it like this. It actually kind of looks, I'm just going to draw it by hand here. If that's any better, I don't know, but that's what we're going to stick to. And so this is 35 degrees. The initial velocity is 25 meters per second. So I got my VI, it's 25 meters per second. I've got my theta, it's 35 degrees. I just kind of like to have that written out to the side even though we draw it on the diagram. Now, what are my X and Y knowns and unknowns here? So you can have VIX, that's your initial velocity in the X direction, and the initial velocity in the Y. You've got your acceleration in the X, acceleration in the Y. You've got delta X, delta Y, all these things, like I said, some of the things we know, some of them we don't know, some we don't care about. I just like to write all of it out. That way we can figure it out as we need to, and sometimes it helps us with like follow-up questions they might give me. So delta T is obviously the same for both of these. And delta T is something that is actually what they're asking us for, so that's what we got to figure out. The initial velocity, remember this initial velocity right here, that's at an angle. So we need to break that angle up. So if I have 25 meters per second right here, and then I've got my X and my Y direction, this is one of the first things we want to do on these problems, is figure out what is my X velocity, what is my Y velocity. So here's my VIY. Here's my VIX. Remember, VIX, here's our angle, it's 35 degrees. VIX is the adjacent side. Which trig function deals with adjacent? Well, it's cosine. It deals with adjacent and the hypotenuse. We know those two things. So I'm going to say 25 times the cosine of my angle will give me my VIX, my VIX. So I'm going to punch that into my calculator. 25 cosine 35. Remember, make sure that your calculator is in degree mode. This gives me 20.5. That's a 0.5. I'm going right in right here, 20.5. And now for the VIY, I'm going to say 25 times the sine of 35. Why the sine of 35? Because this is the opposite side. This is the hypotenuse. You can watch how I do one of the other problems. We set it up as an equation and move on from there. It's just once you've done enough of these, you just start writing it out. It kind of saves a little bit of time. So I'm going to punch that in my calculator now. Or if you don't have a calculator, you can look it up on a chart if you like doing it the old way. We get VIY. This was equal to VIY, by the way, is equal to 14.3. And this is in meters per second. This right here is meters per second. I just ran out of room to write it. Now, we know in our X direction that the acceleration is 0. In the Y direction, for this class, on these type of problems, we're using -10. The delta X we don't know. The delta Y we do know, because it goes same level to same level. We know that the delta Y is 0 meters per second. And one other thing I meant to put on here, we didn't. We could put our initial and final velocities, not just the initial velocity, because that can be helpful too. We know that the final y velocity, well, if you start off with an initial velocity of 14.3, that's going upward. When you're going downward at the same level, you're going to have the same magnitude of velocity, but it's going to be in the opposite direction. So you're going to have negative 14.3 meters per second there. Why does that help? Because when we look at our equations, there's several we could use here, but there's one that we refer to as VVAT. That looks like this. And remember, when we did one-dimensional kinematics, we used VVAT, and we didn't specifically say whether it's in the x or the y direction. So when we get to this, we can use this equation again, but we want to always make sure that we're putting in here which direction we're talking about. This one I'm going to use as the y direction. So this is our VVAT in the y direction. I know that the final velocity is negative 14.3. It's very important we have that direction written down on there. The initial y velocity was positive 14.3. The acceleration is a negative 10 meters per second squared, and the delta t is what we're trying to find. So I'm going to subtract 14.3 from both sides. I get negative 28.6 meters per second is equal to negative 10 meters per second squared times delta t. Divide both sides by a negative 10, and I get 2.86 seconds is equal to delta t. So there's my time. Now, I know that the problem didn't ask for it, but we can go ahead and take it one step further and say, what if they asked, how far away is this skillet going to land? Or in other words, what is delta x here? Well, I know my time. My time is 2.86, so since delta t equals 2.86, I can say that, hey, delta x must equal the rate that I'm going, which is, in the x direction, it's 20.5 meters per second, times how long I'm going at that rate, which is 2.86 seconds. It's meters per second right here. And that should make sense. This is an equation. When you look at the equation, if I write it out without the variables in there, it's delta x equals your average velocity times delta t. That should make sense. If I'm traveling down the road at 20 miles per hour, that's what I'm averaging, is 20 miles per hour, and I'm on the road for 5 hours, and I ask you, how far did I go? If I'm going 20 miles per hour for 5 hours, we should say, okay, 20 miles per hour times 5 hours, that's 100 miles I've gone. You've done this a bunch. You take your average rate times how long you're going. We know that this is our average velocity because there's no acceleration. So if there's no acceleration, the initial velocity is going to be the final velocity, and it's really going to be the instantaneous velocity at any point in the trip. So with no change to the velocity, that means this is also the average velocity. So taking 20.5, timesing it by 2.86, I'll get the total distance traveled, which is 58.63. Once again, that wasn't asked for in our question, but it's very possible you could have that question asked to you on a quiz or a test or something like that. Hope this helps with this video. Be sure to check out the other ones to see if that's any help for you while you're completing these problems.